Hello. So I want to go through an example of a little bit more complicated of a balancing chemical reactions. And what makes this one just a little more complicated is that it has some of those polyatomic ions. So those ions that contain more than one atom. I'm still going to start by looking up each piece on my formula sheet to see what are the symbols and the charges. So lead 2, according to my formula sheet, is Pb and has a +2 charge. Nitrate is NO3, so it's got 1 nitrogen and 3 oxygens, and it has a -1 charge. Now when I go to sodium carbonate, sodium is Na +1, and then carbonate is CO3, so a carbon with 3 oxygens, and is a -2. And then each piece is going to still have that same charge at the end. So I've got carbonate is -2, and then my lead is still a +2. And then sodium is still Na. With a +1 charge. And nitrate is still going to be NO3. With a -1 charge. And so from here, I'm ready to start building my reaction equation. So I'm going to start turning these names into formulas. So for lead nitrate, I need 2 nitrates to go with that lead if I'm going to end up with a total charge of 0. So I'm going to put my nitrate in parentheses. So I have NO3, and then I've got a little 2 after it. So if I have that +2 charge from the lead, and then 2 -1 charges from my 2 nitrates, I've got a total charge of 0. So then for sodium carbonate, I'm going to need 2 sodiums to go with my carbonate. And then that reacts to form. That just tells me I'm going to the other side of the reaction, so going from reactants to products. And then lead 2 carbonate, because the lead has a charge of +2, carbonate has a charge of -2. That's a nice easy formula. I just need 1 of each. And then sodium nitrate, again, because they have the same charge, I'm not going to need any subscripts. It's just going to be 1 sodium and 1 nitrate. Now, to think about the balancing, I like to go 1 piece at a time. So if I start with my lead, I start with 1. I'm going to go ahead and draw my particle diagram to help me get a visual of where I'm at. So I'll split reactants and products, and I'm just going to scroll down to get myself a little more space here. So if I start with lead nitrate, I've got Pb. Now when I'm drawing my particle diagram for that nitrate, it is very important that the nitrogen and the oxygen are separate atoms. So I do have to draw a nitrogen with 3 oxygens attached. And then I'm going to do that a second time because I've got 2 of everything inside the parentheses on that Pb NO3. So next I'm going to do my sodium carbonate. So I've got 2 NAs. And then I've got a carbon, and I've got 3 oxygens. Again, even though we're doing a lot of thinking with that carbonate as all one thing, for the particle diagram with what we're trying to communicate, the individual atoms that are making this up, it is important to show each of those separately. And then I have lead 2 carbonate, so Pb with a carbon and 3 oxygens. And then I'm going to do my sodium nitrate. Now, one thing that can be helpful as a starting point when we're dealing with polyatomic ions is to start by essentially treating them as just one thing. That's going to work really well in this case because I start out with nitrate and I end up with nitrate. I also start out with carbonate and end up with carbonate. So if I take a look, the nitrate starts out unbalanced. I have 2 at the beginning and only 1 at the end. So I'm going to start out by dealing with that one. So I'm going to go ahead and try putting a 2 in front of my sodium nitrate. So now if I do that on my particle diagram, I have to draw the entire sodium nitrate a second time. And I'm drawing it as a separate group rather than attached to the original one because they're not bonded together. It's just that I have 2 of them hanging out. So when I have a coefficient, it's just how many of that group are showing up. All right, so now my nitrates are good. I have 2 nitrates, and I have 2 nitrates. I can also check my leads. I have 1 lead at the start, 1 lead at the end. So that's good. I have 2 sodiums at the start. I now have 2 sodiums at the end, so that one checks out. I have 1 carbonate at the start and 1 carbonate at the end, so that checks out. Now if I prefer, I can also check this in terms of the individual atoms that make up these polyatomic ions. And sometimes if the polyatomic breaks up over the course of the reaction, that can be useful to do. So if I just real quick do a check that way, I start out with 2 nitrogens, I end up with 2 nitrogens. I start out with 1, 2, 3, 4, 5, 6, 7, 8, 9 oxygens total. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 oxygens. And I start out with 1 carbon, I end up with 1 carbon. So with both ways of thinking about it, this balancing checks out.